So let's continue with our practice problem on operational amplifiers. So this is another question where we have to find out the ratio of output voltage to input voltage, assuming that this operational amplifier is ideal and the multiplying factor small n is not equal to 1. So with this in mind, once again, if we look at the topology of these resistors, we can spot a voltage divider straight away. This is that voltage divider, and from our understanding of voltage dividers, we know that we are interested in the voltage at this node, and if we can find out the voltage at this node, because the op amp is an ideal one, then the voltage at this node will be the same as the voltage at the other end, so at this node, and therefore after that we can apply the concept that whatever is the incoming current to this node will be the same as the outgoing current from this node, and use that principle to find out the expression for the output voltage to the input voltage. So that's the target for approaching this sort of problem. So first thing is, this is our voltage divider, and therefore the voltage at this node is given by this resistance divided by summation of both the resistances R and NR, and then multiplying it by V0, and therefore this becomes equal to R divided by R plus NR multiplied by V0, and cancelling out these R's will lead to Vx being equal to 1 by 1 plus N times V0. So this is the voltage at this node, and therefore Vx over here will be the same because of the concept of virtual short, and therefore we can proceed with the KCL at this node, which is given by, if this is the incoming current I1, then I1 can branch into I2 and another current that can enter the input terminal of the op amp. But because this is an ideal op amp, the current that enters the input terminal of the op amp is 0, and therefore I1 is equal to I2. So we can frame the expression as Vi minus of Vx divided by R, and this is equal to Vx minus of V0 divided by R. So once we do that, we find out that Vi is equal to 2 times Vx minus of V0, and then we substitute the value of Vx, which was equal to V0 by 1 plus N, and this was obtained from that voltage divider concept. And so once we substitute it over here, we obtain 2 times V0 by 1 plus N minus of V0 is equal to Vi, and we proceed with this little algebra and find that V0 by Vi is equal to 1 plus N by 1 minus N, subject to the condition that N is not equal to 1. So once again, this is a very simple problem, but the idea behind putting this sort of practice problems is that we can be comfortable about spotting the voltage dividers and then understanding the concept of virtual short and being able to frame the nodal equations.